Good morning, good evening, good afternoon, and welcome back to another math lesson. Today we're going to be moving on to lesson 2, analyzing rational functions. We're going to split this into two separate lessons. The first lesson we're going to talk about specifically reciprocal functions and doing transformations of them. Okay, so let's get started. So recall a reciprocal function of the form y equals 1 over f of x. So what we're going to do first is we are going to sketch y equals x and then the reciprocal y equals 1 over x on the same graph using the table of values. Okay, so what we can do is we can fill in the y equals x table of values portion of this first. Okay, so it's going to follow just like this. So when x is -2, y is -2, when x is -1, y is -1. I think you can get the pattern of this. So 0, 1 over 4, 1, and then 4. Okay, so the graph will look like this. Okay, so that's what the original graph will look like. Okay, so what we're going to do now is we're going to fill in the y equals 1 over x. Okay, so let's go ahead and let's do that. So when when x is equal to -2, y will be the reciprocal of that. So that's going to be -1 over 2. Okay, when y is -1, okay, when x is -1, y is also -1. Okay, but this one, when x is 0, well, that's going to be 1 over 0, okay, which is undefined. Okay, so that does not exist at that point. Okay, when x is 1 over 4, well, the reciprocal of 1 over 4 is just going to be 4. And then finally, when x is 1, y is 1. And when x is equal to 4, y is equal to 1 over 4. Okay, so what we're going to do is we're going to add in an asymptote. Okay, and the asymptote is going to be at x is equal to 0. Okay, so let's go ahead and let's add that in. And just a reminder that all asymptotes are drawn in using a dotted or dashed line. Okay, so make sure you do that as well. Add arrows at the end. Okay, and we can label it. This is going to be x is equal to 0. Okay, also for a reciprocal graph, we also have another asymptote, and this one is at y is equal to 0. Okay, so we'll go ahead and let's add arrows at the end of that. And we can say that this is y is equal to 0 as well. So what we'll do now is we will graph this reciprocal function. We know that when x is -1, y is -1 for both graphs. So what we can do is we can add in those specific points on this graph. So we can say that these are our invariant points. Okay. So they're the same on the original graph and also the reciprocal graph. Okay, so they are the same. So let's create our curve. So it follows along the asymptote, comes down, will touch this point, this invariant point, and then it'll follow along the other asymptote. Okay, so this is the behavior of these reciprocal graphs. It'll touch the point. Okay, let's fix that line a little bit here. Okay, so it'll come around, it'll touch this invariant point, and then keep going. Okay, so this is the behavior of this particular graph, and you can go ahead and you can check this out for yourself. I mean, when x is equal to 1 over 100, for example, so again, 1 over 100, okay, you're going to get, again, really close to 0, but not quite 0. Remember, 1 over 100 is like 0.01. Okay, but when x is 1 over 100, right, y is 100. So it gets really, really, really big. So that's why the graph is trending towards the asymptote. Okay, so it's trending in the positive direction in that case, okay, for your y values. Okay, when x is getting really, really big, right, so we have the example of 4, for example, okay, it's the reciprocal of it is 1 over 4. Okay, which means it's getting closer and closer to 0, but it actually will never reach 0, right? So in that case, that's why the graph is trending towards these particular directions. Again, you can think of it as, right, you just set yourself up with x equals 1, right, equals 10, equals 100, and you can kind of see the pattern in which it's going. Okay, you can also go in the reverse direction, right, where you go, when you can go, like I had 1 over 100, you go 1 over 10, right? 1 over 1,000, right? You can see the direction it's going, okay? You can also do the same thing in the negative direction as well to see how these particular graphs are made, okay? But that is the curve, and this is how we're going to use this graph, the y equals 1 over x, moving forward, okay? And we will do transformations with these particular graphs, okay? So let's try some out. Okay, so now we're moving on to recall graphing reciprocal functions with transformations. So we're going to move on now and do transformations with the function, right, y equals 1 over x. Okay, so we're going to move this graph around, right, left, right, up and down. We could even stretch it vertically, as also stretch it horizontally as well. Okay, so let's move on to the first one. So it says sketch the graph of y equals 1 over x plus 3 and write the domain and range. Okay, so in this particular case, when we have an x plus 3 in the denominator, this is telling us that we're going to move this to the left by 3. Okay, so we're going to move this, we're going to pick up the graph of y equals x and move it to the left 3. So this is going to be our horizontal transformation. Okay, so let's graph this out now. A couple things we can look for as well is we can look for our x-intercepts. It's always good to look for our x-intercepts, and we can also look for our y-intercepts as well. Okay, so let's look for our x-intercept. So that means we have to set y equals to 0, right? So if we have 0 is equal to 1 over x plus 3, well, in this case, in order for us to get the x plus 3 out of the denominator, we'd have to multiply both sides by x plus 3, and anything times 0 is 0, so that means that this is still an we are still going to have a y asymptote at y equals 0. Okay, so because there's no x-intercepts that exist there, okay, so we will still have it, in this case, this is undefined. Or y-intercept, we're going to set x is equal to 0. Okay, so we have y is equal to 1 over 0 plus 3. Well, 0 plus 3 gives us 1/3, so the y-intercept is at 1/3. Okay, so now that we know that, we can graph the particular examples there. Now, since we are only moving the graph to the left, okay, our invariant points will remain at the same spot. Okay, so we'll make a quick little note for ourselves and say that the invariant points, right, will be at y equals -1 and 1. So again, we're moving the graph to the left by 3, so that means the asymptote is going to move to the left 3 as well. So it was at x is equal to 0 before, but now it's going to be at x is equal to -3. And you can figure that out by, you can put that particular number in, right? If x is equal to -3, well, then you go -3 plus 3, which gives you 0. 1 over 0 does not exist. Okay, so we'll go 1, 2, 3 and draw a dotted or dashed line to signify that this is an asymptote, right? We can say, okay, x is equal to -3. And we'll make another one. As we found out, there are no x-intercepts, which means we have an asymptote at this point at y equals 0. Okay, so we will still have our invariant points. Okay, so it's going to be at y equals 1 and y equals -1, but we also have a y-intercept at 1/3, so we can draw and put in a 1/3 there as well. Okay, so what we'll do now is we will graph this particular reciprocal function. Make sure to touch all the points. There's 1, there's 2, and then it keeps trending towards in this direction, like so. And we can do the same thing over here in this quadrant. So there you go. So if you want to graph the domain and range, or you want to state the domain and range, so you can say that the domain for everything is going to be x, such that x is an element of the reals. So x is every single number, but x cannot equal -3. Okay, and you can say the same thing for your range, except with y, obviously. Y can be everything, but y can't be 0. Okay, and that's because of your asymptotes there. Moving on to the next example, we have sketched the graph of y equals 1 over x plus 2, and we're going to write the domain and range. Okay, so from our previous example, we had a number underneath, okay, underneath the fraction, so in the denominator of the fraction, and that caused us to move left and right. Okay, so now we have a number that's outside of the fraction, and so what this number is going to do is we're going to move up by 2. Okay, so we are going to actually move this, pick up the graph and move it up by 2. Okay, so now, because we've moved it up by 2, that means the only thing that's changed, okay, is our y asymptote Okay, so the y asymptote is now at y is equal to 2. Okay, so that graph has actually been picked up and moved up, so that y asymptote is now at y is equal to 2, which means our x asymptote, so our vertical asymptote. Okay, so let's... will be at x is equal to 0. Okay? Okay, so let's go ahead and let's draw those out. So we have our x is equal to 0. And now we also have our y is equal to 2. Okay, so now because of that, our invariant points have moved as well. Okay, so our invariant points, we'll just call it IPs for short. So our invariant points have now moved. They've also moved up by 2. So instead of it being now at y equals 1, it's now y is equal to 3. And instead of it being at y is equal to -1, well, now it's at, well, oddly enough, y equals 1. Okay, so those are our invariant points now. So at y equals 1, or sorry, -1, and y equals 3. We can also find our x-intercept. So let's go ahead and let's find our x-intercept. Because our horizontal asymptotes moved up, we can now find our x-intercept. So let's set y to 0. Okay, so with this, again, it's going to be y is equal to, or sorry, 0 is equal to 1 over x plus 2. Okay, so in this case, we'll move the 2 to the other side. So now it's going to be at -2 is equal to 1 over x. Okay, so in this case, what you can do is you can actually switch spots. So the x will switch spots with the -2, so that it's now x is equal to -1 over 2. So that's our x-intercept. So there you go. Okay, so let's go ahead and let's graph that. Again, it follows the same pattern as the regular parent function y equals 1 over x. Okay, so we just want to make sure we get all these points drawn like so. Make sure, see, I had to redo my line there. Make sure that your lines don't cross or don't hit the asymptote. Okay, so if you have to redraw it, then that's okay. You redraw it. Okay, but we have to make sure it doesn't cross or touch the asymptote. Okay, but there you go. That is how this particular graph is drawn. If you want to write the domain and range, okay, the domain, let's write it another way, is going to be everything but. So it's going to be -infinity for domain, right? All the way up to x is equal to 0. So all the way up to 0, not including 0, plus 0 to infinity. Okay, and the range is going to be very similar. Okay, so we have -infinity all the way up to 2, right? Not including 2, right? And also 2 to infinity, not including 2. Okay, so it's basically just shown that. Okay, so there you have it. That is example number 2. Moving on to example number 3, we have sketched the graph of y equals 1 over -3x plus 6. So in this case, okay, what's happened is, because everything is under the denominator, so everything's in the denominator right now, let's factor that first, okay? Then we can decide how this graph is moving or if it's being stretched or not, okay? So let's just rewrite this so that it's y equals, and when we factor the denominator, it's 1 over -3, okay, x minus 2. Okay, so that is how our particular graph looks. So what this means is this -2 means we are going to move to the right by 2. And this -3 is going to tell us that we are being stretched by 1/3, sorry. And there you're going to flip over the y-axis. Okay, so let's go ahead and let's remap this for us, okay? Okay, so we want to make sure that we find our new asymptotes, okay? So we have to find a number that makes this denominator 0, Okay, so in this case, it's going to be 2 because we've basically picked up and moved the graph over to the right by 2. So that's where our new asymptote will be. Okay, so 1, 2. So that's where our new vertical asymptote will be. Okay, and again, that's all by just understanding what the transformations are telling us and remembering and recalling what the original y equals 1 over x asymptotes and where they are. Okay, and because of that, we've moved this graph over by 2 to the right. So that's where the new asymptote will be. Okay, since we did not move it up, we will keep the same horizontal asymptote at y equals 0. Okay, arrows at the end. Okay, so now if we were to look at our invariant points, okay, so if we're going to look at our invariant points, okay, again, it's 1 and 1 and -1, -1. If we're going to apply this transformations to it, we're going to move them, we're going to stretch them by a factor of -1 over, we're going to stretch them by a factor of -1 over 3, okay, and then move them to the right by 2. So how it basically looks is we're going to go x over -3 plus 2, and we're doing nothing to the y's. So -1, so this is 1 over -3, so this is -1/3, right? You just replace the x in there. And you're going to add 2 to it, so you should get 1 2/3. If you write it as an improper fraction, that is okay as well, and we leave the y alone. This next one, we have -1 divided by -3. Well, that's 1 over 3, and you're going to add 2 to it, so that's 2 1/3. Okay, and again, your y is still the same. So those are our new invariant points. Okay, so they're still, right, they're still at y equals 1, but they're in a different spot. Okay, so again, it's going to be at y, or x is 2 over 3. So x is 2 over 3, 1 over 2/3. Okay, so it's going to be 1 2/3. About there. Okay, and your other invariant point will be down here at 2 1/3. Okay, so this is 1 2/3, and this is x is 2 1/3. Okay, so those are our new invariant points. So we can go ahead and now and graph this particular function. So again, it's going to follow. Oh, you can also find, so before we do that, actually, let's find our y-intercept. So we are going to set x is equal to 0. Okay, so in this case, it's going to be y is equal to 1 over -3, right? 0 minus 2. So the basic is going to be -3 times -2, so y is equal to 1 over 6. Okay, so that is our other point that we can graph. Okay, so let's go ahead and let's make this graph. Right, touches these points. Like so. And we do it in the other quadrant as well. Oh, make sure we don't touch the asymptote, right? Come up, meet the point, and carry on. Just like that. Okay. So there you go. That's how you would graph y equals 1 over -3x plus 6. Okay, moving on to example 4. All right, it says, given the graph f of x below, sketch the graph of the reciprocal function. So in this case, we are not given an equation to graph. Okay, so we have to figure out how this reciprocal function graph will look. Okay, so essentially what we need to remember, okay, is wherever it crosses the x-axis, okay, whenever y is 0, okay, that's where our vertical asymptote will be. Okay, so in this case, it's going to be 1, 2, 3, 4. So at x is equal to 4, okay, that's going to be our vertical asymptote. X is equal to 4. Okay, again, it's wherever it crosses the x-axis, right? Because that's when it's y is 0, but the reciprocal of 1 over 0, that does not exist. So that's why it's at x is equal to 4. Okay, and then we can also, because this graph has not been moved up, it's a linear function. Okay, so because it's a linear function, we can safely say that we have a horizontal asymptote at y is equal to 0. Okay, so now that we have that, let's draw our invariant points. Again, wherever, right? So again, your invariant points is wherever y is equal to -1 and 1. So those are your two spots, okay? So one invariant point will be at y equals 1, and here's the other one at y equals 1. Now you sketch the shape of the graph. So again, you would follow along the asymptote, touch the invariant point, and continue. Okay, to about the edge of the graph. And you do the same thing along the other side. Okay, so again, what we need to do is we need to figure out where it crosses the x-axis. Okay, that's our vertical asymptote, or our x-asymptote. Okay, and then if we need to figure out if the graph has been moved up or down. Since this particular graph is a linear graph, it hasn't been moved up or down. Okay, even if it has, it's still, our horizontal asymptote will still be at y is equal to 0. Okay, but that is how you would do example 4a. Moving on to example B. So again, what we need to do first is find the asymptotes. So we're going to find the vertical asymptotes. Okay. And how do we do that? It's wherever that's whenever crosses x-axis. Okay, so wherever your parent function crosses the x-axis, that is where you will find your vertical asymptote. There we go. Okay, so in this particular graph, it's going to be located here. Okay, at x is equal to 2. And since it's a parabola, it'll be mirrored at x is equal to -2. So x is equal to -2. X is equal to 2. Okay, so those are our asymptotes there. And we'll also find another one here at y is equal to 0. Okay. So you're probably wondering, well, how do we find, when does the horizontal asymptote move? We'll get into more detail on that when we go through more on rational functions in the next lesson. Okay, so for this particular one, again, we want to find all of our invariant points. So find our invariant points. Okay, so those are at when y is equal to 1 and -1. Okay, so in this case, there will be 4 points. Okay, so let's go ahead and let's graph those. So we have one here, 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 and here. Okay, so and finally the last bit. Okay, mainly this centerpiece. We'll find out what this particular the centerpiece will look like. So what we'll do is we'll take this vertex, and we will find out the reciprocal of that. Okay, so this is -4, where y equals -4. So the reciprocal of that will be y is equal to -1/4. So that means the new reciprocal function is actually going to start here for this particular section of the graph. Okay, let's go ahead and let's graph the far left one first. So the far left section is going to look very similar to the sections we've drawn previously. Okay. The far right section, it will also look the same as well, as it should be mirrored because it is a parabola, so it should look the same, just flipped onto the other side. The middle portion, okay, is going to look like a parabola that's turned upside down. Okay, so it's going to come up, it's going to touch that point, touch the other point, touch the last invariant point, and go straight back down. Okay, because again, as closer you get to 0, right, for your y's, the reciprocal of that actually gets really, really, really big. So that's why we're trending back towards the asymptotes, okay, in this particular case. Okay, moving on to the next example. So again, what we need to find first, and we need to find our x or vertical asymptotes, okay? So again, that's wherever the graph crosses the x-axis. In this particular case, since the graph does not cross the x-axis, so does not cross x-axis, right? That means that there are no vertical asymptotes. Okay, so that's what this particular graph means. But we still do have a y = 0 asymptote. Okay, so we can still add that part in. So we will still have a graph, or we will still have an asymptote at y = 0. Okay, so what we'll do now is we will map out some particular points. Okay, so mainly these three, 1, 2, 3. Okay, solely because those are the actual points that meet there, right? Where we can have y = 1, y = 2, and y = 3. Okay, so if y = 2, right, the reciprocal of that is a half. When y is equal to 3, the reciprocal of that is 1/3. So those particular points will end up down here. Okay, so what this graph will do is it will actually follow along the asymptote. All along the asymptote, it'll come up and touch these particular points, come back down, and carry on. Okay, so that's how this particular graph would look. If you're being asked to find the domain and range, well, your domain will be everything. X is the element of the reals. Okay, there are no restrictions on X in this particular case. Whereas the range, your range is going to be 0 is less than y, which is less than or equal to a half. So it's in between, your y's are in between those values. It won't reach 0, it'll get infinitely close to 0, but it'll never reach 0, but it will reach a half. Okay, so that's the domain and range for this particular example, and that is how you would graph the reciprocal function for this example. Moving on to the last examples for this particular lesson, it says, given the graph of y = 1 over f of x, sketch the original graph f of x. So what we are trying to do is we are trying to figure out what the original graph used to look like given the reciprocal graph. Okay, so it's kind of like we've learned how to graph reciprocal functions given the original. Now let's work backwards. So it's kind of like we just learned how to multiply. Now let's learn how to divide. Let's reverse the direction. Okay, so in this particular case, we want to look for our invariant points, right? Y is equal to 1 and -1, and let's find all the asymptotes. Okay, particularly the vertical ones, because that's where our original graph crossed the x-axis. Okay, so if we look at example 5a, 5a has a vertical asymptote at x is equal to 1, 2, 3. So that means our particular graph has a point at, or it crosses the x-axis at x is equal to 3. Okay, and then we find the other invariant points. Okay, so at y = 1 and -1, and because of this, we can now safely say that this graph looks like a linear graph. Okay, so we can go ahead and we can sketch this, connect the dots, draw a line, and that's it. Okay, so again, from there, that is what the original graph f of x looked like. Okay, so all we did was we found where the vertical asymptotes were, okay, found the invariant points, and connected the dots and graphed. Okay, so let's try again with b. B, now we have a parabola. Okay, so but we're going to do the exact same thing. Let's find out where they cross the x-axis. By doing that, we find where the vertical asymptotes are. So this is going to be at x is equal to -2, and then -3, 4, 5, 6. Okay, so because of that, we can safely graph those points there. Next, we'll find out where this particular vertex would be. So the reciprocal of y = 1 is still y = 1. Okay, and the other invariant points is where y is equal to -1. So it's at these points here. And we have enough data now to graph. So this is going to look like a parabola that's opening down. Just like this. Okay, so that is how this particular graph will look. How do we know that it's trending or it's opening down? It's because of the far left and the far right version of the graph, okay? Or you could look at it as it's the opposite direction in which the middle part of the reciprocal graph is going. either or works in that it works in your favor. Okay, moving on to C. Again, what we need to do is we need to find where our vertical asymptotes are and our invariant points. So our vertical asymptote in this case is going to be at x is equal to 0. And our invariant points, well, we only have 2 this time, and they're going to be at y is equal to -1. So in this case, it looks like that we will have a parabola that's opening down with a vertex, okay, at x is equal to 0, okay, and y is equal to 0. So it's going to look like this. Okay, and how do we know that it's opening down? Again, it's based off of the left and right because they are both opening down as well. Okay, because they're also in quadrants 3 and 4. Okay, so that's one way that you can determine where the graph is opening. Okay, moving on to the final example. Okay, so again, in this particular example, what we need to find is our vertical asymptotes. Because there are none, okay, we can assume that this is going to be a parabola that's opening up or down, that's either above or below the x-axis, okay? Next, we'll do our invariant points, okay, at y is equal to 1. So there's 2 in this particular case. And then what we'll do is we'll take a look at this little vertex here, and we'll take the reciprocal of it, and that's where our original graph's vertex would be. Okay, so this is going to be at y is equal to, what's this? Y is equal to 1, 2, 3, 4. So the reciprocal of 4 is going to be 1/4. So it's actually going to be way down here. And since this entire reciprocal graph is above the x-axis, we can assume that our original graph will also be above the x-axis. So it's going to be opening up. Okay, so let's create our parabola for our original parent function. Just like that. Okay, so that is how you would do this particular example. Well, that is it for today's lesson on reciprocal functions and transformations. I hope you enjoyed it. Again, when it comes to math, keep calm and show your work.